Hello. In today's practice lab, I will be using a variety of technologies that you have encountered during CCNA study, including routing, port security, EtherChannel, DHCP, NAT, PPP, and frame relay. I will start doing the configurations on the routers one at a time, and at the end, we will be able to ping from any PC in this topology to any device. I hope my videos are helpful for those who are seeking to be certified for the Cisco exams. If you like my videos, please subscribe to my channel and share it on your Facebook page and give me the thumb up. And please let me know if you have any suggestions, comments, or questions. I will gladly answer you back. On my Facebook page, I created a group and have all the practice labs I created listed in it. If you want to do more labs, just send me a request to add you in this group and enjoy doing the labs with the walkthrough. The group is called CCNA Free Practice Labs Walkthrough. On the description of this video, you will find two files, one for the packet tracer source files and the documents to walk you through the lab step by step until you finally will be able to verify the configurations you did during this lab. Now I will start with router 1. I will configure the interfaces on router 1. Nothing is configured in this topology yet. So on router 1, enable, configure terminal, the host name, router 1, the interface of gig 00, and this is with the IP address of 172.16.10.1/24 subnet mask, and enable the port with a no shut, and the interface serial 000, and this is with IP address of 10.1.1.1/30 subnet mask. Enable the port with a no shut, and the serial or the link with router 3 interface of serial 001. This is with IP address of 10.3.3.1/30 subnet mask, and enable the port with a no shut. Here now on router 1, I will configure DHCP on the router just to show you how easy this can be done. On the global configuration, exit here, IP DHCP excluded addresses. I will exclude from 172.16.10.1 to 172.16.10.5, just 5 IP addresses. Enter. And the pool, I will call it simply pool with caps. IDP, IP, DHCP pool. Now the network of 172.16.10.0/24 subnet mask. And our default router will be the interface on gig 00 of 172.16.10.1. So now on the PC, here PC1, just click on the IP configuration and click on the DHCP radio button here, and it sure is give us this IP address of 172.16.10.6. Next, on switch 1, I will configure VLAN 10 on the switch and configure it to receive the IP address from the DHCP server. Switch 1, enable, configure terminal, host name, SW1, create the VLAN, which is VLAN 10, and now on the VLAN 10 and the IP address, just to go to the DHCP server to get it. Enter. Next, I will configure router 2. As you can see, we need to do another configuration on the switch. Just later on, I'll do that. So you will see it that it received its IP address. Now on router 2, enable, configure terminal, the host name of router 2. Here on router 2, we have 4 interfaces. The interface of gig 0, 1. This is with IP address of 172.16.20.1/24 subnet mask. Enable the port with a no shut. And the other interface facing the internet of gig 00, and this is with IP address of 209.165.200.225/27 subnet mask of 255.255.224. Enter. And again, enable the port with a no shut. Now the interface facing or the link with router 1 on the interface of serial 000, and this is with IP address of 10.1.1.2/30 subnet mask, and enable the port. And the other interface with router 3 on serial 001, this guy with the IP address of 10.2.2.1/30 subnet mask. And no shut. Now here I will configure a default route, and the exit interface would be on the gig 00. A default route here, this exit interface to the internet on router 2. The global configuration, simply type IP route to any network with this subnet mask and the exit interface on gig 00. Next, I will configure the internet router, this guy here. Enable, configure terminal, host name, internet. Now on the internet router, we have 2 interfaces. The interface of gig 00, and this is with IP address of 209.165.200.226/27 subnet mask 224. Enter, enable the port. And the other interface of gig 01, and this is with the IP address of 8.8.8.1/24 subnet mask, no shut. Now on the internet router, I will configure a default route with an exit interface on the global configuration, IP route to any network with this subnet mask, and the exit, our interface would be on the gig 00, this interface here to any network. So now I will configure router 3. We have 3 interfaces need to configure here. Enable, configure terminal, the host name of router 3. Now the interface of serial 001, and this is with IP address of 10.2.2.2/30 subnet mask, 252. Enable the port with a no shut, and the other interface with connecting to router 1, and this is with IP address of 10.3.3.2/30 subnet mask, and enable the port with a no shut. And finally, the interface of gig 01, this is with IP address of 172.16.30.1/24 subnet mask and a no shut. So I configured all the interfaces on the routers. Now I will configure port security to allow PC1 access the switch 1 on the port F01 interface, and any violation should disable the interface. So now moving to switch 1, need to do some configurations here. Exit. First, let me configure this interface on the switch of gig01 connecting the switch to router 1 as an access port to VLAN 10, which we configured on the switch. First, interface gig01, switch port mode access, switch port access VLAN 10. And let's wait for a second to see if it will receive its IP address from the DHCP server configured on router 1. This is still amber here. Change the color. But now let me work on Pass Ethernet 01. Interface F01, switch port mode access, switch port. Now finally it received the IP address, switch port mode access, switch port access VLAN 10. This is for the port F01. Now enable port security, switch port security, switch port security, maximum can hold only one. This is how we want to configure it. Switch port security, and the MAC address we want it to be sticky, and switch port security. If any violation, just go ahead and shut the port down. Next, I will configure LACP, Link Aggregation Control Protocol, on the switches. Now, within the IEEE specification, the Link Aggregation Control Protocol, LACP, provides a method to control the bundling of several physical ports together to form a single logical channel. So now on switch 3 here, enable configure terminal. The host name of this switch, we want to simply name it as W3. I'll create VLAN 30. Now on the configuration of VLAN 30, I will give it the IP address of 172.16.30.2/24 subnet mask. And the default IP default gateway for this would be 172.16.30.1. So this would be the gateway. Now the interface between the router, this interface or this link between the router and the switch should be configured as a trunk. So back on the switch, the interface of gig 01, switch port mode trunk, enter. Next, I will configure EtherChannel on the switch. We have these ports F01, F02 connecting to or connected to switch 2, and we have the F03, F04 connecting switch 3 with switch 4. So on switch 3, the interface range of F01 and 2. Channel group, we have here it's 1, and the mode is auto. Now I'll exit from here, and on the port channel we just created, which port channel 1, bundling these two ports together, switch port mode trunk. And the other interfaces, the range of F0, 3, and 4. Channel group 2. The mode is auto. I'll exit from here, and on the port which we created, port channel 2, switch port mode trunk, enter. Now we are done with switch 3. Let's move to switch 4. Enable, configure terminal, host name. Simply I'll name it SW4. Now here I'll create configure two VLANs, VLAN 11 and VLAN 30. Enter. Here on switch port, we have this port, which is F05, because we have 1, 2, 3, and 4 are taken. Now the next in line, which is port 5, I will connecting the switch to the PC as an access port, VLAN 30. So on the switch, interface F05, switch port mode access, switch port access VLAN 30. Now I will configure EtherChannel, the interface range of these two ports F0, 3 and 4, connecting switch 4 to switch 3, channel group, and here we have channel group 2. The mode is desirable. Here, because we configured the mode on switch 3 as auto, from switch 4 it will be desirable. Exit, interface of port channel 2, which we configured, switch port mode trunk. Now the range of F0, 1, and 2, channel group. Now 1 and 2 are connecting switch 4 with switch 2, and channel group 3. 3, mode desirable. Enter, and now exit. Now enter, it's port channel 3, switch port mode trunk. Now on switch 2, enable, configure terminal, host name as W2. again, I will create two VLANs, VLAN 11 and VLAN 30. Now we have two ports F01 and F02 connecting switch 2 to switch 3. The interface of range of F01 and 2. Channel group, as you can see, it's 1. The mode, because we configured in switch 3 as auto, here it will be desirable. Enter, and I'll exit. Now, the port channel we created on the switch, which was number port channel 1, switch port mode trunk. Now, the ports connecting switch 2 with switch 4, interface range of F0, 3, and 4. Channel group, this is a 3. Mode, auto. Exit. Interface port channel 3. Mode trunk. Let me run this command on the switch, show interface trunk. Here, what we configured, we have port 1, channel group 1, and channel group 3. This is it showing us here. Next, I will configure dynamic routing protocol, OSPF, on the routers with the process ID of 1, and I will configure it so no routing updates should be sent across interfaces that do not have routers connected. Now on router 1, enable, configure terminal, router OSPF 1, router OSPF 1. Now we have these three networks here, the network of 172.16.10.0 with the inverse subnet mask of 000.255 in area 0. Network, 172.16.10.0. Oh, come on. Sorry, guys. Network 172.16.10.0 at 255 in area 0. Finally, and the other network between connecting router 1, the link between router 1 and router 2 of 10.1.1.0 with the inverse subnet mask of 000.3 area 0, and the other network of 10.3.3.0 with the inverse subnet mask of 000.3 in area 0. The link between router 1 and router 3. Now we have the passive interface on the gig 00. Now we have a question. Why do we use the command default information originate? We use this command if a static route has been configured on the router. Just bear with me a second. Now we will explain this. Enable, configure terminal. Sorry guys, it's almost 5:30 and I still have another maybe 2.5 hours, of sleep to go to work. So it took me almost most of the night, making this video. And just sorry about these typos. Now on router 2, router OSPF 1, OSPF 1. Now we have these three networks. We actually have 4 networks But that's why I will explain why we use the command default information originate. Now, the network of 172.16.20.0 with the inverse subnet mask of this and area 0. The other network of 10.1.1.0 with the inverse subnet mask of 000.3 in area 0. And the other network of 10. The other network of 10.2.2.0 with the inverse subnet mask of 003 area 0. Now our passive interface of gig 01, the one connecting the LAN here, our LAN and with the TFTP server. The fifth directly connected network is this network here on the gig 00. And with the IP address of 209.165.200.0/27. This wouldn't be advertised because we configured a static route for the network connection connecting to the internet. Therefore, we will configure a command to advertise this network using this command. This is what I told you about default information originate. Enter. Now, router 3. Enable, configure terminal, router, OSPF 1, the network of 10.3.3.0 with the inverse subnet mask of 003 area 0, and the other network of 10.2.2.0 with the inverse subnet mask of this area 0, and the third network of 172.16.30.0 with the inverse subnet mask of 000.255 in area 0. And our passive interface on the gig 01. So I'm done configuring the dynamic routing and protocol OSPF on the 3 routers. Next, we will configure NAT. I will configure NAT on router 2, and no untranslated addresses are permitted to cross the internet. We have a class A and class B addresses here, the 10.1.1, class A, the 10 here, connecting the links between the routers, and class B with 172.16.0.0 here. So on router 2, we want the IP addresses to be translated to go to the internet here. So simply what we will be doing from the global configuration, first I will configure the access control list on the router. IP access list standard, I will simply call it access, all caps, enter. Now we want to permit the network of 10.0.0.0 0.255.255.255, and the other network of, or networks of 172.16.0.0 0.255.255. Enter. Now we want to NAT inside. This is our source, and it was in the list we created, 2 lists. We named them access, interface on the gig 00, and not to forget the word overload. Now we have the interface on gig 00 facing the internet. This is IP NAT for outside, and the interface of gig 01, this is IP NAT inside. The other interface of serial 000 IP NAT also in our inside networks, and this one IP interface 001, this is to IP NAT also inside. So we are done with configuring NAT on router 2 to translate IP addresses to the internet. Now we will work on WAN technology. I will configure the serial link between router 1 and router 3 to use frame relay. On router 1, in the global configuration mode, on the interface which is connecting router 1 with router 2 on serial 000, encapsulation frame relay. Now, no keep alive. Enter frame relay interface DLCI. I'll give it this number. Define a switched or locally terminated DLCI 222. Enter. Now, what does keep alive mean? Keep alives are used on the router's interfaces as hello mechanism to check the end-to-end connectivity to the other end. Routers interface use this mechanism to check the interface status. If you have no keep alive command, it means that interface status check mechanism is disabled and router will not transmit any. Now, what does the DLCI stand for? Stands for Data Link Connection Identifier, DLCI, and it is a frame relay 10-bit wide link local virtual circuit identifier used to assign frames to a specific PVC or SVC. Frame relay networks use DLCIs to statically multiplex frames. DLCIs are preloaded into each switch and act as road signs to the traveling frames. Now we configured on router 1. Let's work on router 2. Exit here. Now, on the interface, the link between router 2 and router 1 on serial 000, encapsulation, frame relay, enter, no keep alive. Now it's back to up. Frame relay interface, I will use the same number of 222, enter. Now, let me talk a little bit about the HDLC encapsulation. I will cover this in a separate video. HDLC stands for High Level Data Link Control. A transmission protocol used at the data link layer, which is layer 2 of the OSI 7-layer model for data communications. The HDLC protocol embedded information in a data frame that allows devices to control data flow and correct errors. Now, where is HDLC protocol used? It's simply a protocol used to connect point-to-point serial devices. For example, you have a point-to-point leased line connection connecting two locations in two different cities. HDLC would be the protocol with the least amount of configuration required to connect these two locations. Now, what is HDLC and PPP? Here the difference. The major difference between HDLC and PPP, which is a point-to-point protocol, is that HDLC is the bit-oriented protocol, while point-to-point protocol is the character-oriented protocol. The HDLC and PPP are the crucial data link layer protocols used in WAN WAN stands for Wide Area Network, where HTLC can be implemented with point-to-point protocol for the efficient results. Next, I will configure the serial link between router 1 and router 3 to use PPP with PAP. Point-to-point protocol is a data link layer, which is layer 2 communication protocol between two routers directly without any host or any other networking in between. It can provide connection, authentication, transmission, encryption, and compression. Now I will work on router 1. Here on I will configure two usernames, router 3 and CCNA on router 1. On the global configuration mode, perhaps exit on router 1, username router 3 with the password of Cisco, the other username of CCNA, and password of Cisco. Now the link between router 1 and router 3 on the serial 001. So on the interface of serial 001, encapsulation PPP, PPP, authentication, PAP, PPP, PAP, sent user, router 1, with a password of Cisco. Now we are done with router 1. So let's jump on router 3. And here it's showing us detached. Let's configure router 3. Also, I will configure two users here. User name router 1 with the password of Cisco, and another user, call it CCNA, with a password of Cisco. Now the interface of serial 000 connecting router 3 with router 1, encapsulation PPP. Now PPP authentication, we'll use PAP, and PPP PAP sent username router 3 with a password of Cisco. Next, here now I will configure a sub-interface on router 3 for VLAN 30. But before I do this, I need to delete the configuration I did on this interface of gig 01. So on router 3 here, exit, I will go straight to the interface of gig 01 and simply type no IP address. So we don't have an IP address configured on the switch, on the interface. Now, the sub-interface of gig 01.30, because for VLAN 30, enter encapsulation .1q for VLAN 30. And this is with IP address of 172.16.30.1 with /24 subnet mask. We know that the interface of gig 01 is up, but to be on the safe side, gig 01, no shut. The physical interface, but we configured a sub-interface on of gig 01.30. Now, let's verify some connectivity here. So let's see if PC1 can ping the TFTP server. Or what I hear on the command prompt, ping 172.16.20.245. And it is. Guys, what I want you to do here now, when you are done, when you reach this point of the configuration, just like now, I pinged from PC1 to PC to the TFTP server, ping from PC1 to the outside host, ping from PC1 to PC2. And now on the router, I listed for you some of the show commands that you just do it on the router. Just run the command show IP interface brief on router 1. And the command should run and study each line in these configurations or in the results, and run also the command show IP route OSPF. Also show IP route or show IP DHCP pool. On router 2, we configured NAT here. Also, when you run the commands, from the inside to the internet, from PC2, PC1, or the server to the internet or to the host here, go to the router 2 and run the command show IPNAT translation, show IPNAT statistics, show the access list. Study these commands, one at a time, and whatever you study, just do it here, and just to get to know, be familiar with these show commands. Just keep ping, do show question mark, and just go through the protocol. See, don't make. You are free. You reach this point on the lab, everything is pinging, okay, how did this work? Type show IP, the interfaces, just for the interface. Type show IP route or show IP OSPF. Show IP route OSPF question marks. Just see what else that you can know about these kind of commands. I hope you learned something from this video. I hope when you do it that you it's something that you really love to do, and you if you have any questions, comments, please write me, on Facebook, or on the video itself on YouTube, and I will, if you have any suggestions also, please don't hesitate to write me. Thank you so much for watching, and I'll see you soon in my next video. Have a nice day.